Hey guys, and welcome back to my CCNA 200-301 course. Patrice is here, and in this video we are going to talk about management options. Are you ready? Let's get started. Cisco devices are feature rich and depends on the platform you use. Not all of those features are enabled, and if you want to benefit from those features, you need to configure your device. So you need management access to the operating system that is running on that device. And to be able to do that or have management access to your device, there are multiple ways. The first one is console, and this requires physical access to your device, and you have to connect your console port to the device and run an application to be able to use that. I spoke about the console port in the iOS basic commands video. The other protocols that's been listed here, they require IP connectivity to your device. So if you are the network administrator and you want to configure this device, first of all, you need IP connectivity or a network between these two. So these two should be able to have IP connectivity first, and then you can use protocols like Telnet, SSH, HTTP and HTTPS to manage this device. I spoke about the basics of Telnet, SSH, HTTP and HTTPS in the application layer protocols video, and you can review the basics of these protocols there. Some Cisco devices are cloud managed, like Meraki devices, and we spoke about them in the Cisco wireless networks video. And basically you connect your device to internet, and then from a single pane of glass that is provided by Cisco, you can manage your devices through that cloud-based services. TACACS and RADIUS are not remote access protocols providers. I mean, you cannot use TACACS and RADIUS to connect to a device like Telnet, SSH, HTTP or HTTPS. But these protocols help us to implement AAA. So somehow they are related to management access. So Cisco put them in the topic. AAA stands for authentication, authorization, and accounting. And I will be talking about it in a few minutes. All right, this is our today's scenario. As you can see, a router is being implemented in Event G, and it is connected to gig 1 to my home network, so I can provide that IP connectivity to my device. The first thing you need to do is changing the host name of your device if it is on the default host name. So you remember this command from the previous videos. Host name, and then you change the host name to whatever suits you. And the next thing you need to do is creating that IP connectivity to be able to access that device through SSH, Telnet or HTTP, HTTPS. So I go to int gig 1 and I say IP address and 192.168.1.200 with this subnet mask, and then no shutdown. And to be able to test my connectivity, I ping my local machine, which is 192.168 and then 1 and 2, 10. Okay, it looks like there's a problem. Let's try IP routing and then ping 192.168.1.1.210. And there we go. We have the IP connectivity now. So the next step is setting a domain name. This domain name doesn't have to be resolvable, and it can be anything. We just need it to create the SSH keys for encryption. So we go to global configuration mode and we say IP domain name and set it as like test.com. And then it's time to create the SSH keys. To create SSH keys, you can say crypto key generate and the algorithm, which is RSA. And the keys can have different lengths from 512 to 4096 from memory. It might be different on different platforms. But anyway, these key lengths can be different and it's up to you. If you're following specific policies, you have to use that specific key length, etc. If you want to do that, you have two options, either using modulus option here and set your key length, or if you don't do that and just press enter here, the prompt will ask you, this is the range of keys you can set, and this is the default value. If you are okay with that, just press enter. Otherwise, put your desired key length here. I just press enter, and this will create SSH keys for us. The next thing is we have to have a username and password to log in to our device when you want to connect remotely to your device. To set that username and password the command is username. And here I put my username, for example, admin. And here, like enable password, if you remember that we had enable password and enable secret. The difference was that when you set enable secret, your password will be presented in the running config and the startup config in encrypted format, and the default algorithm is MD5. But if you just use password, your password will be presented as clear text. And if you use service password encryption command, that will encrypt it, but that algorithm is reversible. So if someone has that encrypted version of your password, they can easily decrypt it. Same things happening here. So you can have username and password, or username and secret. In some situations, like setting PAP and CHAP, which are authentication protocols for serial links, you may still have to use username and password, but in recent setup, it is always recommended to use secret. But you can change that algorithm by using this option, and this is algorithm type. And so here, if you say algorithm type, you have a few options. MD5 is the default one. So if you say secret, it will be using MD5, but you have two other options to make it more complex and using more complicated encryption algorithms. So you can use script or SHA-256. It's up to you. I don't want to use it here now because we are just in a test lab, and I just use other option, which is secret, and then put my password, Cisco 12345, for example, and this is my password. If you want to give the maximum access to your user, before this, we have to say privilege 15, which is the highest access level to your users. And then we put the secret here, and then Cisco 12345. So now we have set a username and password on our device to use it for authentication purposes. The next thing is enabling access through Telnet and SSH to your device. To do that, we have to go to our line configuration, and the line for incoming traffic for Telnet and SSH is called line VTY. The initial Cisco devices only had 5 different lines to connect through Telnet and SSH. So you could have 5 concurrent Telnet or SSH connections to your device. But after some time, they increased it to 16. So it's up to you to use line VTY 0 to 4 to configure the first 5 lines or configure line with device 0 to 15. So you configure all 16 available lines here. And the command is login and then local. And this means that I want to use the local username and password I just defined to log in through this line and use these credentials to use through this one. If you do it on a Cisco device, this will enable both Telnet and SSH on your device. But as I mentioned in that application layer protocols video, Telnet is not secure and it will transport the communications, whatever, your commands, your credentials, etc. in plain text mode. And it is always recommended to disable Telnet on the devices. So if you want to do that, and I would strongly recommend that, we can restrict the access through the SSH only. And the command is transport and then input and just say SSH. And this will not allow your devices, your users, to use Telnet to connect to this device. Okay, now if I want to test it, if I say other and change it to Telnet, you can see that the port is changing to 23. And now if I say 192.168.1.200, I should get an error message that this device is not accessible, something like that, connection refused. So the device doesn't allow you to connect through Telnet to that device. But if we change this setting to SSH and say 192.168.1.200 here, now I should get a prompt about the SSH keys. And you can see that because these SSH keys are locally created, created on the device, it's not trusted by default. So you have to accept this encryption key. And then the prompt pops up and you're ready to put the credentials you just configure on the device. So I say admin, and then the password is Cisco 12345. If I put it correctly. No, it wasn't. Cisco 12345. And there we go. So now I'm using my IP network to access this device remotely, so I don't have to be in the same location as the device. Configuring HTTP and HTTPS gives you two options. The first one is using your web browser to access that device and configure it with the options that are available on the provided web server of the device. And the other option is using RESTconf, which is a protocol that can help you to use automation tools and configure your devices through RESTconf, which is using HTTP and HTTPS for communications. We'll be talking about the automation stuff in the upcoming videos. To configure HTTP and HTTPS, again, like Telnet and SSH, HTTP is not an encrypted protocol, so everything gonna be transport in clear text format. So it's up to you to use HTTP and HTTPS both, or just HTTPS. First of all, you need to enable your web service, and the command is IP HTTP server for HTTP and IP HTTP secure -server for HTTPS. And the next thing you need to do is, like what we said in the line VTY, we said login local, which means that we want to use our local database, the username and password we defined in the device for the authentication purposes. And the command is IP HTTP authentication and then local. And this actually will enable those credentials we just defined to allow us to connect to the device. So now if I open a new page here, and if I go to 192.168.1.200, you can see that again, a warning comes through because of that certificate, because it's locally generated on the device and it's not a public trusted certificate authority. We got this error message. We accept the certificate. It's a self-signed certificate. And now we can use our credentials to log into this device. And there we go. We have our web interface that we can use it for monitoring and configuration of the device. HTTP and HTTPS configuration is not on the CCNA 203/01 course exam topics, but I just configured it to show you how you can use these protocols to also use them to manage your devices. A few verification commands. One of them is show SSH, which shows you if you have any SSH communication on your device. You can see that connection 0, the version is 2, SSH version 2, and the mode is in, means someone is connected, encryption algorithm, HMAC algorithm, state of the session, and who was the user who connected here. And also show IP SSH, which shows you some information like if SSH is enabled on your device, what is the version, 1.99. Basically, SSH has two versions on Cisco devices, version 1 and version 2. And obviously it is recommended to use version 2 when you are using SSH. 1.99 means that both versions are enabled on your device. So on this device, both version 1 and version 2 is enabled. And what are the different algorithms is using and what are the SSH keys? If you want to restrict the access to SSH version 2, you say IP SSH version and then 2, and this will restrict your version to IP version 2, SSH version 2. So if we run show IP SSH once again, you see that 199 is changed to version 2, which means that it only works with version 2, not both version 1 and 2. The other verification command you can use show running command, and you can restrict it to section line. So you see your line configurations, including line console, which is the console port, and line VTY. You can see that line VTY is separated in two different sections, 0 to 4 and 5 to 15. So when you configure 0 to 15, you're actually targeting both of these two sections. And login local and then transport input SSH. And for HTTP and HTTPS, similar thing like show, run, and then using include option and say include HTTP. Show me all stuff that includes the HTTP. So you can see that you have the IP HTTP server set up, you have the IP HTTP authentication local, and you have IP HTTP secure server. It's time to talk about RADIUS and TACACS+. RADIUS stands for Remote Authentication Dial-in User Service, and TACACS stands for Terminal Access Controller Access Control System, and plus, TACACS+. And these two protocols help us to implement AAA, as I mentioned before. AAA stands for Authentication, Authorization, and Accounting. Authentication means who is allowed with what credentials to access your network. And authorization means who has what level of access and can do what. And accounting means actually logging who did actually what on the system. So you have logs for auditing. If something goes wrong in the network, you can figure out what changes have been done on the devices and by who. TACACS+ originally introduced by Cisco and was a Cisco proprietary protocol. But after a while, Cisco published the the details of this protocol, and now it's the publicly accessible, and many other vendors also support it. But Radius, since the beginning, was a standard protocol, and everyone could use it. Radius uses port 1812 and 1813 of UDP. 1812 for authentication and 1813 for accounting. And Cisco uses port TCP 49 for all purposes. One of the other differences between Radius and TACACS Plus is Radius only encrypts the passwords or credentials, but TACACS Plus encrypts all traffic. And so we can say that it's a bit more secure in compared to Radius. To benefit from AAA, you need a software. It can be many options, but speaking of Cisco, the option is Cisco ISE, which is my favorite product, Identity Services Engine. Identity Services Engine actually can have a local database of users. So you define the users that need to connect to the devices and being able to manage your devices locally on the ICE, or you can have some external identity sources like Microsoft Active Directory. So you connect ICE to AD to talk to each other and verify if that user is allowed to connect to the network device and manage it or not. So if a user wants to access this router, for example, based on the configuration you did on the device, the router will go to the ICE and ask if this user is allowed to connect to the device or not. And if the user is local, ICE will check the local database, or if the user is supposed to be on Active Directory, for example, ICE will ask the Active Directory if these credentials are valid, and if Active Directory says yes, and if that user is authorized based on the configuration you did here to access that device, the ICE will give the thumbs up to the device that this user is allowed to connect to the device and run the management things that he needs or she needs. And this is happening for authorization as well. So whenever user runs a command, the device check with the ICE if this user is allowed to run this command or not based on the authorization settings. And also whatever this user is doing based on the accounting setup will be logging in the ICE and will be returned for a certain amount of time that you configure it. So if you need an audit and if something goes wrong on the network and you need to figure out what happened in the network, you can check these logs and figure out what has been changed on a specific device or devices. The configuration of this scenario is out of the scope of CCNA 200-301 course, and the only thing you need to know for exam purposes is how these two protocols are involved in management access. Alright guys, this was our today's video. We covered two exam topics in this video. 2.8, describe network device management access, Telnet, SSH, HTTP, HTTPS console, TACACS, RADIUS, and cloud managed. And also 4.8, configure network devices for remote access using SSH. And in the next video, we'll be talking about DHCP configuration and verification. I wish you enjoyed today's video and see you in the next ones.